Welcome to a lesson with Dr. Powell. Let's take a look at an optimization problem in calculus. We're going to be finding the maximum area of a rectangle inscribed inside of a parabola. The parabola is given by this equation here. This parabola is symmetric about the y-axis. Notice we have not shifted it to the right or the left. It's just been shifted up 9. There's a stretch reflect here vertically, but really so this is the y-axis right in the middle. All right, so we want to know what this xy coordinate is as it moves up and down, so we get a maximum volume of such a rectangle. So what we want to maximize is area, so let's find a formula for area, and that'll give us our function that we want to do calculus on to find a maximum output of it. All right, in particular, to simplify things for ourselves, if we maximize the area of this, it's the same thing as maximizing the area of half of the rectangle. So let's just look at half of the rectangle. Let's let our function represent half the rectangle, and it'll depend on x, the coordinate, as we move along here. Now what would that be? So just this half right here. Well, this length is x, of course, moving to that point, and this length up and down is y. The area is just equal to x times y. Hey, y is just that, right? So x times negative 3x squared plus 9. And that's equal to a of x. Now, take a derivative of that, a prime of x. But before we do that, let's multiply it out. Negative 3x cubed plus 9x. So now let's factor a 3 out before we go any further. In fact, let's factor a negative 3 out. Okay, so let's just think of this as negative 3x cubed plus, in fact, we can factor, let's just factor out a constant, negative 3. I'm not going to factor out an x because, a constant factored out before we take a derivative is a good thing because you can pretty much ignore it. That constant will just stay there as we go to our second derivative. Let's take a look at this. Negative 3 times quantity, x cubed. Okay, well with the negative, I have to be careful because I'm going to multiply through. I'm going to want to get a positive, so that must be negative 3x. So you can just double check, negative 3x cubed and positive 9x. Okay, great. So when you take a derivative, even product rule if you like, or boxing or something. So this, you take a derivative, the first part, it's 0. Boom, out of the water. Next part, you leave this alone, take a derivative of the next part. So really, you're just leaving this alone, and it's still there with the derivative. So negative 3 times, and then the derivative of this part, which is 3x squared minus 3. Okay, so look, we can factor another 3 out of everything. So negative 9 times x squared minus 1. Where is this equal to 0? Well, when x squared is equal to 1. When x is equal to plus or minus 1. In fact, if you think about the graph of this, the derivative is a downward parabola itself going through plus or minus 1. So that means the original function, which is the area of that thing right there, it goes, this is derivative is negative here, and positive here, so it goes down, then it goes up, and then it goes down. Looks like getting a maximum right here. And truly, this will represent kind of a similar maximum, but negatively, if you look at it, because you're getting, let's see, the x-coordinate will be negative, because it's like a negative x-coordinate times the y. So there should be kind of some symmetry, but we're interested to know what this right corner point is anyway. So really, we'll just be interested in this one. It looks like this gives us a maximum area right there when x is equal to 1. When x is 1, you can throw it into y, and notice that you end up getting 9 minus 3, which is 6. So the point is 1, 6. That would give you a maximum area right there. We could see that from that sign analysis, but we could have taken a second derivative and gone a little bit further. Second derivative, okay, so right here, okay, this is still the derivative right here. So if we take the derivative of this, using that constant alone outside, you just take a derivative of this part, which is 2x, and then that part's gone. It's 2x. Notice, so this is the second derivative. If you were to plug in x is 1, it's negative, concave down, maximum. Second derivative test works as well. Thanks for watching.